Let's be real. If you want to land a job as a JavaScript developer, you need to solve algorithm challenges like a boss. Today is day 11, and we are diving into the three-sum problem, a popular question in coding interviews. And here's why you will love this. Mastering three-sum gives you an edge in interviews. You write efficient, clean code using technique top developers that relies on. The skills you pick up today will make your code faster, clearer, and interview ready. This isn't just another challenge, it is your chance to get better, solve real problems, and boost your confidence for when it really counts. So, ready to crush it? Let's jump right into it. First thing, let's understand what is the problem we are trying to solve today. You are given an array of integers, and the task is to find all unique triplets where the numbers add up to make a zero in total. But there is a catch. The same triplets shouldn't appear twice in the result, and all the numbers must come from different positions in the array. So the pointer A should be different than pointer J, it should be different than pointer K. Now, how we can approach this problem? This can seem complex, but we'll make it easy with two-pointer technique. So first thing, we will sort the array so it is easier to find and skip duplicates. And we'll use three pointers. One fixed pointer should be I, and two dynamic pointers, we should call them left and right. Then we'll adjust pointers to find triplets that sum to make a zero. When it comes to algorithm, how we can treat this? The first step will be to sort the array from the smaller to bigger, and then we will loop through the array with the I pointer from 0 to the nums.length minus 2. And for this each I pointer that we created, we'll use two pointers that will be dynamic, left and right, to find the triplet. We will skip duplicate values for both I and pointers to avoid repeated results, and in the end we will store the valid triplets in the result list. Now let's start coding. I defined a function that accepts an array of numbers, and what we'll do firstly is that we'll declare a new array that we will store our results into it. So we'll create a const, we'll call it result, and that will be initialized to an empty array. As you remember, we said the step number one will be to sort the array. So that's what we will do. Nums dot sort, so we use a sort function in JavaScript. And what we will do, we can store it ascending by using the following: a comma b, and return for us a minus b. Simple way, and this is a common way of sorting in JavaScript. Now next thing is step 2, loop through our array. So we will use the for loop, and we will define our pointer I that will start from 0, and we will keep looping as long the I is smaller than nums dot length minus 2, and then we will keep incrementing by 1. So we can loop through each number in our array. So every time we land on one number, we said we'll create two dynamic pointers, okay? A left pointer and a right pointer. But first thing, we have to skip the duplicates of I. So that is an edge scenario. So skip the I duplicates. And the way you can do that, we use the if statement. If our I is superior than 0 and our element at that pointer I, if it is equal to the element before, it means it's a duplicate, I minus 1, then we'll just continue. Oops, should be outside. Then just continue, which means it will go to the next number. Now, if you don't have duplicates, then we'll create our pointers. So step 3, create the dynamic pointers. So we'll create our left one, so let left, and that will be equal to our I plus 1, so the element after our current element. And we'll create another one, which is the right pointer, which will start from the end of the array, and that will be equal to nums dot length minus 1. So that will be pointed to the last element in our array. Now we'll use a while loop, and the reason why we have to be doing this as long our left pointer it is smaller than right our pointer. Okay, so if you see this example, if the left pointer is here, then that's not a valid case scenario. It means to be equal to our right pointer. So we want to do this runs and checks and fill in our result array as long the left pointer is always smaller than the right one. So as we move also the left pointer to the right will keep moving to the left. It should be always the left pointer smaller than the right, then it's a valid scenario for check. So as long the left is smaller than the right pointer, then let's do the following. We'll create a constant we call sum, and that will be equal to nums of your current pointer, so your current number, plus nums of your left pointer, plus nums of your right pointer. Great. Now we will check if our sum is equal to 0. Then we want to store these new values in our result array. So we'll say result dot push, and we'll push our new array. So it will be nums at I, then it will be nums at left, and it will be nums at right. Great. Now we have to do few checks. So we have to skip duplicate values for the left and the right. So how we can do that? We'll use again, use a skip duplicate of left and right pointers. So we use a while loop again. So we'll say while the left is strictly smaller than the right pointer, and nums at left if it is equal to nums at left plus 1. Okay, because you're moving your left pointer to the right, right? So if when you're checking now and you create your new array and you push it, before we move on, we have to check, is the next value at that left pointer, is it same as my current one? If it is, then move my left pointer one step ahead. Okay, same thing we will do for the right pointer. So while, and I hope now from this you may have a basic understanding how you'll do for the right pointer, but it is almost same logic. So while the left is smaller than the right, and nums at right pointer, and the right pointer is going to move to the left side, okay, which means we have to check nums at the right pointer if it is equal to nums at right minus 1. Okay, if it does, that means they have the same value. We don't want to use them to fill in a new array. We just move our pointer, but now as we said, we move the right pointer to the left side. That means right minus minus. And here I did a problem. I need to do a triple equal, so it checked the value and also the type. Okay, so we handled our left and right pointers. If it's all good, everything's happy, then we have to move our left pointer plus plus and right minus minus. And if you're asking why, like in this scenario, if we move our left pointer to the right, that means the left value, for example, it will have the next number, okay, which is already to have the same value of my current one. So with these checks done, we are just moving to the next same value. And of course, that same value already used it to fill an array here. We don't need it. We still have to move again one step ahead for the next round of the I. Okay. Now, all this if our sum is equal to 0. Now, if not, else, if our sum is smaller strict than 0. So we got a negative number. That's mean we need a larger sum. Okay, so if your sum is negative, we need a larger sum, and for that we move our left pointer. Okay, so left plus plus. Otherwise, that's mean you have your sum strictly bigger than 0. We'll do the opposite. So else we'll do right minus minus. Great. So this will do for us to check and fill for out the array. When all this is done and everything is happy, in the end we just return our result array. Okay. And what I have done, I added some console logs here for us to check. So we'll go and run our code and see if this is working. So this is the output expected to the first one, and I can compare them. They're the same. The second one is an empty array, which is good, and second one is just triple zeros. So now if you want a detailed explanation again or recap of this, what we have done here. First step we did is we sort our array. It helped us to manage duplicates easily and apply the two-pointer approach. Second step, iterating with the I pointer. So we use a for loop to fix the first element in the triplet. Then we are using in the third step two dynamic pointers. One pointer to the left and start just after the I, and the other pointer, which is the right, at the end of the array. In the first step we are checking the sum. If the sum is 0, store the triplet and skip duplicate. Then in the fifth step, we are just adjusting the pointers. So if the sum is less than 0, move your left pointer to increase the sum. And if the sum is greater than 0, then move your right pointer to decrease the sum. Now, what are the takeaways of today's video? First thing, sorting helps manage duplicates and make it easier to use the two-pointer approach. The two-pointer technique improves efficiency to O(n) squared time complexity, and this problem is a must-know for JavaScript interviewers, and now you can solve it like a pro. And there you go. Boom, you just cracked the three-sum problem using JavaScript. This is a popular question in interviews, and now it is in your skill set. The techniques you learned today, like handling duplicates and using the two-pointer approach, will help you write better and more efficient code. So keep up the great work. Every day you're becoming a better developer, and don't forget to like, share, and subscribe so you never miss a challenge. I will see you tomorrow for Days 12 challenge. So let's keep leveling up together.